Go. So hello, welcome to Electric Field, Electric Potential, and Potential Energy by Sean Mendoza. So hopefully more prepare nito tayo para sa part 2 nung test ni Sir. So I made this specifically para sa Charles kasi hindi kami naturuan nun. So I tried to teach it as best as I can, pero if may mga mali, let's just discuss it sa comment section. Wow, YouTuber. Anyway, dun sa first part ng test, may mga multiple choice. So, ito yung mga sagot. Di ako sure dito sa proton kasi sa internet, hindi nag-agree lahat kung si Goldstein or si Rutherford. So, tanongin na lang natin si Sir sa Monday kung ano yung thoughts niya. Pero, sure na yung ibang sagot dyan. Anyway, next is yung part na may quantity, yung definition niya, and yung possible units. So, ayan na rin yung mga sagot. And yung mga definition and conceptual part of it, mas i-discuss naman natin mamaya. Pero, ito na yung mga sagot. So, memorizing nyo na. And, volts over meter, that's actually electric field. Ganun. Next is the definition of electric field itself. So, electric field, it's a region around a charged particle or object within which a force would be exerted on other particles or objects. So, tignan niyo yung definition. It's a region. So, may area na ina-affect siya around the charged particle. So, kailangan merong charged particle na nakaka-affect. And a force. Dahil dun sa charged particle, magkakaroon ng force. So, meron yung general na formula na KQQ over R squared. So, tandaan nyo na yung R is squared. Huwag nyo kalimutan na i-convert sa coulombs tong Q at ito convert sa meters. Lagay nyo na to sa calculator nyo, ganun. I think ang lalabas dito is nakasenter sa definition at saka sa formula. So, memorizing yung definition and matuto na kayo manipulate ng formula like yung normal na pag nag-double yung charge, ano mangyayari sa electric field, sa electric force, mga ganun-ganun. Pag nag-double yung distance, ano mangyayari, magiging 1/4 yung value ng field actually. Mga ganun. So, ayun. Practice nyo na yan. Next, electric field due to a straight rod. So, formula lang to. So, if may tanong, memorizing nyo lang talaga siya. And mag-practice na kayo mag-plug in ng values. So, KQ over R times the quantity 1 over the square root of L squared over 4 plus R squared. L, capital L, that's actually the length of the rod, and R is the distance to of the test. This is R. Yan yung distance between the test charge and the straight rod. And baka tinatanong nyo, ano tong R hat? Ibig sabihin lang niya ng R hat is yung electric field ay nagka-come from a certain point and radially outward. So, ayan, fun fact lang yan. Pero, di naman yun siguro lalabas ni Sir. Anyway, just memorize your formula and practice na kayo mag-plug in ng values. Don't forget na naka-coulombs to, ito ay naka-meters, and the same goes for the length and the R. Sa computations, di naman ginagamit tong R hat. So, ayan. Memorize nyo lang talaga tong formula na yan. Then next, baka lumabas tong tanong na to. Oops. Ano daw yung formula of an electric field if yung straight rod mo ay may length na infinity. So, sobrang haba niya. So, ang sagot is lambda over 2 pi r epsilon sub 0. May proof yan, so nandun naman yung proof mamaya, pero basically yan yung sagot. Lambda is the linear charge density, so coulombs per meter yon. Ito naka-meter, ito ay pi. Tapos lagay nyo na itong value na itong epsilon sub 0 sa calculators nyo kasi, ayan, baka lumabas. Yan na, practice kayo mag-plug in ng values dito, pero basically memorizing nyo yung formula. Next, electric field due to a curved charge rod. So, halos same lang naman siya sa straight rod. Aralin nyo lang talaga mag-substitute ng values dito sa formula. Di naman to lumabas dun sa periodic, so I don't think lalabas din yan sa test. Pero, ayun. Ito yung chest charge, ito yung angle, ito yung angle. Kaya niya na yan. Ayan, angle 1. Tapos, angle 2. So, ayan. K, then your charge density, R is yung distance, or yung radius nung curved charge rod, and ayan. So, ayan. Kaya niyan. Go, guys. Wala naman siya, like, hindi ka siya katulad ng straight rod na may infinity. So, yeah, memorize nyo lang talaga tong formula na ito. Electric field due to a charge ring. Actually, ang cool nitong drawing na yan. Yan. So, electric field is equal to KQZ over the quantity Z squared plus R squared, tas naka 3 halves yun. So, ayan. Alam nyo naman siguro yan. Ito yung R, ito yung Z. So, ayan. Mag-plug in lang kayo ng values. Tandaan, naka-meters to, naka-coulombs. Then, memorize nyo lang yung formula. Siguro yung tip ko is, at the start of the test, magdala kayo blank paper, or kaya dun sa test paper mismo, sulat nyo na lahat ng formula. So, para pagdating sa habang nagsasagot, nakasulat na yung formula, di mo na kailangan tandaan ulit isa-isa. So, if the particle, itong distance na yan ay infinity, ang formula ay magiging KQQ over Z squared. So, para lang yung formula nung electric field. So, actually, pag nag-go ka a distance infinity away from a charge ring, nagmumukha na siyang particle. So, illustration yan is ayan. So, from a near distance, ang itsura ng charge ring ay ganyan. Habang lumayo ka ng lumayo, paliit yan ng paliit hanggang sa maging dot na lang siya, which is KQQ over R squared. Or in this case, KQQ over Z squared. So, ayan. Coulombs, meters. Ingat sa units and ingat sa pag-input sa calcu. Next, electric field due to a charge disk. So, para lang tong charge ring, pero yung charges ay nasa surface ng disk. So, ito naman ang formula niya. That's sigma, that's surface area density all over 2 epsilon sub 0, tas tong weird na quantity na ito. So, ayan, memorize niyo yung formula. Mag-ingat sa pag-compute, ingat sa units. And actually, magkakaroon din na ng isa pang thingy, which is if the charge disk has a area of infinity, so like sobrang laki ng charge disk, ito na yung formula for electric field. Ang cool thing about here is nakadepende ang electric field sa surface area charge density nung charge disk. So hindi siya nakadepende dun sa distance nung particle from kunyari ito yung charge disk. Kung ano yung electric field dito, yun din yung electric field dito. 'Di ba? Cool shit. So yan. Actually, isa yung malaking bagay. Tignan niyo yung mga formula ng mga thingy. For example, ito sa electric field from infinitely long straight rod, nakadepend siya sa linear charge density ng straight rod and the distance ng particle mo from the straight rod. So, ayan. Like, pag may mga tanong na, does the value of the electric field increase or decrease as the particle goes away from the straight rod? Ganon. Nyari. Ito yung situation A, ito yung situation B. So, ayan. Ano mas malaking electric field dito? Since yung R dito is mas maliit and yung R dito is mas malaki, and since inversely proportional yun sa electric field dito ay mas mataas, na electric field dito ay mas bumaba. So, yung sagot dun is, as the test particle moves away from the straight rod, nag-decrease yung electric field. So, yeah. Mga ganun. So, matuto rin kayo mag-analyze ng formula kung ano yung may dependent, dependence, and directly proportional and inversely proportional. So, meron naman ditong problem. The figure shows three particles with charges Q1 positive 2Q, Q2 equals negative 2Q, and Q3 equals negative 4Q. What net electric field is produced at the origin? So, pag ganito, mga net electric field, ang unang mong tatandaan siguro is magkakaroon ka ng positive test charge dyan with a charge Q. And net electric field, so ang gagawin is kukuhanin mo yung electric field from here, yung electric field from here, electric field from here, and mag-vector addition ka lang. So, ayan. Next is, drawing mo muna yung arrangement. Kasi nga, diba, para ma-analyze mo yung problem, kailangan mo siyang i-drawing. So, ang ginawa ko dito is, red stands for the positive values, and papalitan ko ba yung kulay na to? Yay, papalitan ko. This stands for the negative values. So, in here, dun sa relationship na ito, gawin natin green. Because why not? Sa relationship na to, anong mangyayari? So, since positive sila pareho, ang mangyayari is magmo-move tong test charge natin to the southeast. Kaya makita mo yung F1 nagpo-point sa southeast. So, gawin muna natin yung X and Y components sa perspective ng test charge. Since magmo-move siya southwest, ang X niya is positive kasi magmo-move sa right. And yung Y niya is negative kasi magmo-move southward. So, makakatulong yan mamaya sa pag-add and subtract ng magnitudes. Pero, yeah. Ito naman, magmo-move siya northeast. So, that's positive, comma, positive. Ito naman, southeast ulit. So, that's positive, comma, negative. Sa perspective ng test charge. So, since ito ay positively charged, negatively charged, positively to, negative to, mag-attract sila. So, dahil sa particle na to, ang test charge is mag-move northeast. So, ganon. So, ayan. Sa mga ganitong problem, net electric force, net electric field, kailangan mo talagang i-drawing, kailangan mong i-determine yung interactions kung mag-attract or mag-repel, and determine mo yung charges nung X and Y components ng electric field kasi makatulong yan sa'yo mamaya. So, ito lang yung formula. The net electric field is the vector sum of all the electric fields. So, vector sum yan not necessarily mag-add ka. So, since nagdi-deal tayo with a problem na may nagdi-deal sa X and Y coordinates, X and Y components, kailangan mo muna siyang i-separate into, kailangan mo muna siyang i-separate into E sub X and E sub Y. So, ganun na yan. So, E sub X equal to the vector sum of lahat ng X components muna nitong arrangement na ito. The same goes for the Y component. Then, mamaya, Pythagorean theorem mo na lang yan para makuha yung E sub net. So, let's go with that. So, nga pala, just a reminder, para makuha yung E sub X and E sub Y na isang electric field, that's just multiplying it with cosine theta. So, mag-ingat kayo sa part na to, lalo na sa theta, and lalo na sa cosine and sine. Kasi minsan, napagpapalit tong dalawang to, and pumapangit because of that. So, yeah, turuan ko kayong paano. So, medyo daming numbers. So, focus muna tayo sa focus muna tayo sa top part. So, E sub 1 is equal to KQ1 over R squared. Yun yung electric field dahil sa particle 1. So, yun ay magiging equal sa 2K over D squared. So, compute mo lang yun. That's just KQ over R squared. And ito na yung makukuhang resultant electric field 1. Then, separate mo lang yun sa kanyang X and Y components, which is cosine theta and sine theta. Since dito naman sa drawing, ang angle between them is 30 degrees. 30 na yun, lalagay mo dun sa cosine and sine. So, repeat mo lang yun sa Q2 and sa Q3. Ang isa nyo mapapansin na ginawa ko dito is wala akong nilagay na sign. Like yung magnitude lang yung kinompute ko muna. And that actually helps. So, ayan. So, summary lang from the further points. So, from when you read the question, hanapin mo kung ano yung hinahanap, net electric field, gawa ka ng working equation para makuha yung net electric field, i-drawing mo yung setup, yung configuration, determine mo yung interactions, ito mare-repel, ito ma-attract, determine mo kung ano yung charge, kung ano yung charge, kung ano yung sign ng X and Y components for each, and then i-compute mo muna yung magnitude. Okay, so na-compute mo na yan lahat. Basahin nyo na lang isa-isa. Then, kunin mo naman yung net force. Ay, net electric field pala, sorry. So, start muna tayo sa X. Sorry. Alam natin na from the E1, dahil yon ay repel, mag-move siya to the west. So, positive to. Mag-remove din to sa right. So, positive yan. Mag-move din to sa right. So, positive yan. So, i-add mo na lang yan dire-diretso, lalabas 8k over d squared cosine 30. And dito naman sa y, ito ay negative kasi nga 'di ba, magre-repel siya, mag-move siya southwest. So, mag-move siya south, so negative. Ito, ma-attract siya going towards southwest, so negative na naman. Ito naman, ma-attract siya going northeast. Oh shit. Southeast to, southeast. Tapos ito, northeast. So, ayan, mag-move siya to the north, kaya positive siya. Ito may negative, ito may negative. So, mag-add yan to 0. Then, pinakita ko lang, compute mo is Pythagorean. Ano ba tawag dito? Nalimutan ko na kanina. Ano to? Adobe Flash. Okay. Oh my god, paano yung tanggalin? Exit. Okay, never mind. So, ayun. At this point, tignan nyo lahat ng computations nyo. Make sure na tama yung mga nalagay nyo sa calculator. Huwag kalimutan yung sign, newtons per coulomb, and ano yung direction, since lahat naman to ay rightward, that's east. Ano pa ba? So, yan, ingat kayo sa units, sa direction, and sa actual na magnitude na na-compute nyo. So, yan, good luck. Kaya natin yan. Next is electric flux. So, bibilisan ko lang tong part na to kasi hindi siya lumabas sa periodics, pero sabihin natin baka bigla siyang lumabas sa test ni sir. Anyway, rate of flow. The electric flux is the rate of flow of the electric field through a given area. So, parang dinedescribe niya kung gaano kadami yung electric field, kung gaano siya kalakas. Parang ganun. So, yan. Keyword is rate of flow. Then next, Gauss law states that the total electric flux through any closed volume is proportional to the total charge Q enclosed inside the volume. So, actually, ito yung formula na yan. Where the phi, where the phi is equal to the Q enclosed over epsilon sub 0. Gumawa na ako ng isang mahabang formula para ma-summarize na yan lahat. So, tama yan. Memorizing nyo yan. Pero what this basically says is, ayun, the phi, the electric flux, is equal to AA cosine theta. So, that's the electric field times the surface area of the Gaussian surface times the cosine theta, which is the theta, the angle between the area vector. So, kung ito yung Gaussian surface mo, ito yung area vector, and the electric flux, kung ano man yung angle na yun. Tuturuan ko kayo paano mahanap yung angle kasi medyo important siya, lalo na sa sine. So, ayan. Next is Q enclosed over epsilon sub 0. So, useful yan sa ilang mga problems kasi magamit mo yung charge inside to find the electric flux. So, ito naman yung mga formulas na sir. V A cosine theta and the integral of E cosine theta d delta A. So, ayan. Magamit natin yung formulas na yan mamaya. And actually, medyo cool siya. Pero yeah, bilis-bilisan na natin. The electric flux through a closed surface is positive if the closed surface enclose a positive or a negative charge. What that means is, kunyari, meron kang positive charge sa isang sphere. Ibig sabihin nun is, yung electric flux through the surface is positive. Yun lang. Positive ito. Ganun lang. Medyo mahaba lang siya, pero useful yan sa mga explanation mamaya. Okay, let's go with the problem. The field is coming out of each face of the box. There must be a positive charge in the box. So, drawing natin yan. These are electric field lines, and as we all know, electric field lines describe the behavior of positive test charges. So, pag may positive test charge ka dito, ang tendency niya is to move outwards dahil sa positive charge. So, yun lang. Ito lang is parang restatement ng statement na ito. The electric flux is positive if may positive na charge inside. Isang sign ng positive electric flux is lumalabas yung mga electric field lines. So, ayan. Pag may lumalabas, positive electric flux, may positive charge. So, ayan. Same goes for negative electric flux. Kung may negative charge dito, ang tendency ng positive charges is to move inwards. So, ayun. Yun lang yan. So, ayan. Pag may pumapasok, that's negative. Next naman is, a field passing through the box implies there's no net charge in the box. So, what this means is, if may pumasok and may lumabas, ibig sabihin, walang bagay dito na nakaka-affect sa line na ito. So, that means there's no net charge. So, parang, if may bagay dito, if may charge dyan, mag-move tong electric field, ganyan, mapapaganon. Pero since walang net charge, walang charge sa loob, straight lang siya. So, isang sign nito is kung ano yung pumasok, yun yung lalabas. So, if you think about it, dito sa first sample, merong 6 na lumabas. Dito may 6 na pumasok. Dito may isang lumabas and may isang pumasok. So, pag in-add mo yun, ito ay 0, ito ay -6, ito ay +6. So, that's one way to determine the charge. Kung ilan yung pumasok and lumabas. So, ito naman is isang problem. What is the net electric flux through the surface shown? So, binigay yung area, 10 centimeters by 10 centimeters. Convert mo yan sa meters. Ngayon pa lang. Find the angle kaagad between the between the electric field, which is ito, and the area vector, which is ito. Yung tip ko is mag-start ka sa electric field, then you will go counterclockwise until ma-reach mo yung tawag dito, itong area vector. So, yan. This angle is 60 degrees kasi kung 30 to, then 60 to kasi 90 degrees yan. So, ayan. So, ayan na. Pa-plugin mo lang yung value sa computation. That's 200 times A, which is the surface area, 0.1 squared times cosine 60, the theta. Lalabas yan ay 1. Ang unit ng electric flux is N over C, M squared, or if fancy ka, voltmeter. Pero ito yung mas tama in this scenario. Next naman is, ito naman, 15 by 15 cm. So that's 0.15 meters. So yun palang convert yun na. Huwag nyo nakalimutan yan. 180 newtons per coulomb and determine the angle. So yun, start ka dito sa electric field dito tayo. And ito yung angle. So, alam ko na yan ay 120 degrees. Kasi 60 to. Tapos 180 to. So, 120 yan. Pero yan. Practice lang kayo maghanap ng theta para ma-solve nyo na kagad. So, yan. 180, 0.15 squared cosine 120 lalabas is negative 81 over 41, and ayan, ang lumabas na flux is negative 2.025. So, pansin nyo dito ay positive at dito ay negative. Bakit? Kasi dito, with respect to the surface, ito ay lumalabas and ito ay pumapasok. Which goes back to our earlier study. Pag may lumalabas, positive. Pag may pumapasok, negative. So, ayan. Next, what is the net electric flux through the cylinders below? So, imagine muna natin itong cylinders as 3D objects, my top surface, left surface, right surface, and bottom surface. Sa top and bottom, merong zero flux kasi ito yung direction ng electric field. Ito yung direction ng electric field. Ito yung direction ng area vector. Cosine 90. That's 0. So, ayan. Dito naman sa left, may pumapasok. And dito sa right, may lumalabas. May tatlong pumasok, may tatlong lumabas. What does that tell you? It tells you that the net electric flux is 0. Kasi, ang number na electric field lines na pumasok ay same dun sa number ng lumabas. So, ayan. Walang straight yan. Ibig sabihin, walang nakaka-affect na charges dito. So, ayan. Isa nga palang bagay sa mga ganong problems na ito is determine nyo kung yung problem is naghahanap ng value like 15 newtons per coulomb, or naghahanap lang siya ng range such as negative, 0, or positive. And dito, since wala namang binigay na values, na-assume ko agad na naghahanap lang siya ng range. So, ayan. Dito naman, same goes, dito ay 0, dito ay 0, dito ay positive, dito ay positive. So, net electric flux dito is positive. Ayun lang naman. Okay. Ito yung mga other problems, pero di ko na siya explain further kasi feel ko di lalabas. Pero feel free to answer. Bibigay ko na lang yung sagot. Ang sagot dito is positive. Net positive. Dito naman ang sagot is 2. I think mga 2 yan. Ito naman, yung problem na binigay ni sir. So, ito baka lumabas. Ewan. Using Gauss' law, find an electric field at any point due to infinitely long cylindrical plastic rod with uniform charge density, lambda. Medyo advanced tong problem na ito. So, and try ko na nga explain. So, first is kuha tayo sa formula ng Q enclosed. So, the charge is equal to the linear charge density times the length. So, para makuha yung charge, kung ano yung value ng charge, kukunin mo yung density times the length. So, ayan. Then, babanta naman tayo sa formula using Gauss' law. Epsilon sub 0 EA cosine theta equals Q enclosed. So, hinahanap yung number of total, hinahanap yung Q enclosed. So, kumuha ako ng formula for Q enclosed based dun sa formula sheet na binigay. Saan yan? Excuse me. Ito. Ayan. Ito yung formula for the Q enclosed. So, ayan. Useful yan. Equal yan sa lambda L from here. So, lambda L is equal to epsilon sub 0 E 2 pi RL cosine theta. Ano yung 2 pi RL? Yan yung surface area ng cylinder. So, formula, pangit ko mag-drawing. Surface area. So, epsilon sub 0 EA cosine theta, ito yun, is equal to lambda L, ito yun. So, overall, lalabas yan. So, electric field equals lambda over 2 pi R epsilon sub 0, which actually is yung formula para sa electric field due to an infinitely long line of charge. So, ayan. Medyo, kung alam mo yung sagot, kung alam mo yung formula, di mo na kailangan i-solve to. Pero kung tatry mo siyang i-solve, ito lang. So, ayan. General tips, if ano yung hinahanap, which is find the electric field. So, kukunin mo yung formula for electric field. Kukunin mo yung sources nun. Ayan. Yeah, medyo at this point, kailangan magaling ka mag-manipulate ng formula. So, yan. Kailangan manipulator ka. Ang tip ko na lang is keep memorizing nyo lahat ng formula and try nyo na lang mag-transpose kung ano yung makita nyo. Ayan. Actually, may nakita akong YouTube video nito. Kung gusto nyo siyang panoorin, pwede nyo panoorin. So, ayan. If lumabas ulit yung tanong na to, yun yung sagot. Memorizing nyo na lang. Sana lumabas na lang ulit yung mga tanong. Anyway. Next, the figure shows a closed Gaussian surface and the shape of a cube of edge length 2 meters. So, length ito is 2 meters, lahat yan. With one corner at x sub 1, y sub 1. So, ito yan. This is 5, 4. The cube lies in a region of space where the electric field is given by E is equal to negative 3i, negative 4y squared j, and positive 3k hat. So, ano ba ibig sabihin ng mga vectors na ito? Isa tong subject na hindi masyadong naturo, pero yeah, try natin explain. Okay. Pag may isa kang vector na may x, y, and z components, yun lang yan. Ito yung x component, y component, and z component niya. And, ayun yung nagme-make up ng electric field. So, start muna tayo sa x component, negative 3. So, ibig sabihin, negative 3, constant yun, wala siyang variable tulad ng y. Y component may y squared siya. Pero balik lang tayo sa x. Negative 3. So, in terms of x, yun ay positive or negative. Since negative siya, ibig sabihin mag-move yun to the left. So, ayan. Kung ito yung positive x, yun yung negative x. Ang electric field vector is paganyan. And lumalabas siya diretso. Kasi, yung electric field mo in the terms of the x component is negative 3. Constant lang siya. So, kung hinahanap mo yung electric flux, magiging 0 na ito. Actually, hindi ko ito kayang explain masyado kasi medyo complex siya. So, nakahanap ako ng YouTube video na mas magaling niya in-explain tong problem na ito. So, I recommend watching this. Lilink ko na lang siya sa description. Pero yun, ang sagot is negative 1.7 times 10 raised to negative 9 coulombs. So, that's nanocoulombs. So, ayan. Ang tip ko na sa problem na ito is panoorin niyo yung video. Itong video na yan. And hope na hindi ito lumabas. Yeah, medyo complex siya, to be honest. Like, super dami mo i-compute. May mga integral na ewan. Pero yeah, panoorin niyo yung video para mas magets niya. So, yan. Hopefully, walang lumabas masyado ng electric flux kasi di naman yung lumabas sa pero. So, yan. Start na tayo sa electric potential. It's the amount of work needed to move a unit positive charge from a reference point to a specific point inside the field without producing any acceleration. So, start lang tayo sa first part. Amount of work needed to move a unit positive charge. So, for example, unit positive charge is a proton. Ang proton ay, kunyari, nasa isang position na ganito. Para ma-move tong proton na to, say, move it to the right or move it to the left, kailangan mo ng work. Kasi, diba, may electric force na nagre-repel na sa kanilang dalawa. And, paano mo mamove yun kung wala kang work? So, yun. Memorizing nyo lang yung definition. And, that's it. Yung formula niya is KQ over R. So, nakadepend lang to sa source charge and nakadepend dun sa distance from the test charge dun sa source charge. So, yan. Meron yung unique value at every point in the field kasi nagbabago-bago yung value ng R. So, ayun. Yun lang naman mga conceptual na tanong regarding electric potential. And let's move to the questions. Ito ata yung number 50 sa periodic pa rin. Hindi ako sure. What is the electric potential experienced by a test charge at 1, 0, when a source charge of 2 microcoulombs is placed at the origin? So, nanap is electric potential. Ang unit nun ay volts. Formula niya is KQ over R. Then, i-drawing mo yan. Origin, meron ditong positive 2 microcoulombs and meron kang test charge here. So, that's 1. Ang tamang sagot dito is more information is necessary. So, ang sagot sa number 50 is E. And that's because of two things. One is itong microcoulombs and the other is yung 1,00. Kasi ito, di mo alam kung meters yan, kung anong unit nung distance dito sa Cartesian plane na to. And yung microcoulombs, that's 2 times 10 raised to negative 6. And wala yung sagot sa choices. Nandun lang ay 9, 18, 20. So, wala sagot. So, i-assume natin na meters yung distance. Yan ay kq over r. Sagot is around 18,000 volts. So, ayan. 18 kilovolts. So, ayan. Pag lumabas yan, E yung sagot. Equipotential surfaces. So, medyo maraming tanong regarding this. So, ayan. Region of space around charges with adjacent points that have the same electric potential. So, kunyari, equipotential surface tong sheet na ito. Kung ano yung potential at this point, yun din yung potential at this point. Yun ay meaning ng equipotential surface. So, fun fact, a conductor has equipotential surface. Okay. Charges on an equipotential surface are static charges. So, ayan. Mga facts lang naman to. Pero ang main yung tatandaan is siya ay regions of space with the same electric potential. So, ayan. Ito yung first drawing. So, ayan. Equipotential, equipotential, equipotential. Ay, joke. Ito yung equipotential, equipotential, equipotential. Isa mapapansin nyo is equipotential surface is always perpendicular sa field line. So, ayan. So, kung ano yung potential at this point, yun din yung potential at this point. So, ayan. There's not much understanding through it. That's just it. So, ayan. No work is done along this path on an equipotential surface. So, kung may equipotential surface ka, moving from one point to another point does not require work. So, yung work is 0. So, baka lumabas yun. Anyway, feel ko lalabas yan. Tatanong ko may problem na ganun. So, equal work is done along these paths between the same surface. So, dahil equipotential surface to, and equipotential surface to, kung ano yung work para gumalaw from this point to this point, from this point to this point, this point to this point, equal lang yan lahat. Kasi equipotential to and equipotential to. Mas mapoprove mo yan with the formulas mamaya. Pero, yun lang yung basics na need mo memorize it. Ito naman yung medyo mahirap. Calculating electric potential from electric field. So, right then and there, ang formula niyan is delta V is equal to the negative integral of the dot product of the electric field vector and delta S. Anong sabihin ng S? S is basically a path. So, a path, anong sabihin nun? Not necessarily X, not necessarily Y, not necessarily Z, just a path. So, mas ma-explain yon maya-maya. Pero, memorize na itong formula na to. This is delta. So, yan ay either positive or negative depending on sa difference. Negative integral, so may integral na naman from F to I. Okay. Given the electric field vector is 40xy I hat, 20x squared j hat, and 2k hat, calculate the electric potential between 2 points, 1, negative 1, 0, and 2, 1, 3. So, sa problem na to, feel ko lalabas na naman siya. The short answer is, ang sagot ay 106. Yan yung short answer. Pero, kung gusto nyo i-explain ko pa ito. So, the first thing you need to understand here is yung 2 points. 1, negative 1, 0, and 2, 1, 3. The gist is, para magkaroon ng electric potential between them, yung particle mag-move from 1, negative 1, 0 towards 2, 1, 3. So, ayan, mag-move siya from the initial point to the final point. So, imagine nyo yun sa utak nyo. Actually, drawing ko siya sa isang 3D Cartesian plane. Ito yung initial point, that's 1, negative 1, comma 0. This is 2, 1, 3. So, mag-move siya from here to here. Pero, balik tayo dito sa formula. ds, the path. So, hindi siya actually nakadepend sa path ng particle mo. Pwede siya mag-move ganyan. Pareho pa rin yung initial at final point niya. Pwede siya mag-move pa ganyan. Pwede siya mag-move straight, ganun. Pero ang initial point niya is 1, negative 1, 0, and ang final point is 2, 1, 3. So, para ma-solve tong problem na ito, kailangan natin siyang i-imagine yung path systematically. So, zoom in tayo. Ang mangyayari is, instead na logically, mag-go siya from the shortest path. 3D nga pala to guys ha. So, imagine nyo na lang. Ang mangyayari is, mag-move muna siya to the x. So, nangyari, ito yung 1, negative 1, 0. Ito ay 2, 1, 3. Mag-move muna siya to the x. So, ayan. Mag-move muna siya to 2, negative 1, 0. Mag-move siya sa 2, 1, 0. Then, saka siya mag-move from 2, 1, 0 to 2, 1, 3. So, anong nangyari? So, kunyari, 2D muna. Ito yung initial mo, ito yung final point mo. Instead na mag-go siya straight or kung ano man, ang mangyayari is, mag-move muna siya along the x, then saka siya mag-move along the y. In this case, kasi x, y, z, mag-move muna siya along the x, along the y, and along the z. So, paano ba makakatulong? Makakatulong yan sa problem solving mamaya. So, drin ako lang ulit yung given and yung formula. So, ito yung first movement from 1, negative 1, 0 to 2, negative 1, 0. Nag-change lang ng x values pero lahat is virtually the same. So, integrate mo muna yung x part, yung I hat part muna ng problem. So, that's negative integral from 1 to 2 for the xy dx. So, constant yung 40, constant yung y. So, lalabas mo yun. So, maging negative 40 times negative 1 integral of x dx 2 to 1. Pwede mo na itong i-plug in sa calculator mo. Lalabas is positive 60. So, yan. Same goes here, negative from 1 to 2 ba to? Oh my god. Typo to. From 1 to negative 1 yan. 20x squared dy. Sa constant yun 20x squared. So that's negative 22 squared. Integral of dy. Lalabas negative 160. Same goes here. Lalabas negative 6. Add mo yan lahat. Lalabas negative 106. So ibig sabihin, as you go from 1, negative 1, and 1, negative 1, 0 to 2, 1, 3, bababa yung electric potential mo. So, mas mataas yung potential dito sa 1, negative 1, 0 kesa sa 2, 1, 3. Kasi, bumaba yung voltage as you go from there. So, yung sagot is, potential. Calculate the electric potential. So, pwede naman ang isagot doon is, yan, 106 volts. So, ayun na yung sagot. Mali ako ng periodic, nag-power of C ako. Sinagot ko 126. And then, mali ako. Power of A pala si sir. Okay. Calculating electric field from electric potential. Dito lumabas sa periodic. So, feel ko din rin lalabas. Pero, the gist is, ito yung formula ng calculating potential from field. The derivative mo lang yon. Ang lalabas is e cosine theta all over negative d delta v over delta s magiging e sub s equals negative gradient v gradient s. So, ayan. Medyo advanced na itong gradient pero focus lang kayo dito. E cosine theta del V del S. So, ayan. Hopefully, di siya lumabas. Pero if lumabas siya, magda-derivative lang naman kayo with respect to the path. So, same, parang ito lang. Hiwalay nyo muna X, hiwalay nyo muna yung Y, hiwalay nyo yung Z. Diba, mag-move lang siya from X, mag-move lang siya ng Y, mag-move lang siya ng Z. So, yan. Hopefully, di yan lumabas. Next is electric potential energy, the capacity for doing work which arises from position or configuration. So, ayan. It's that's inversely proportional to kinetic energy, which is derived from the law of conservation of energy. Kasi nga, diba, habang gumagalaw ka, tumataas yung kinetic energy mo and bumababa yung potential energy mo. So, ayan. It's given from the formula KQQ over R. So, ayan. Nakadepende yan sa charge ng dalawang particles and sa distance between them. So, ayan. So, try natin isang sample. Isang positive and isang negative. Tapos isang positive and isa pang positive. So, right off the bat, ang sagot dito is initially ganyan, tas finally maging ganito yan. Anong nangyayari? Ang electric potential energy nito is negative. That doesn't mean wala siyang energy. That just means its potential is negative at this point. And dito naman, nagiging paano tayo erase? Hirap. Okay. What the hell? Cool. Okay, anyway. Wow, nagka-cut pens and needles na. So, initially, ito yung position nila. Positive, negative, ang tendency nila ma-attract sa isa't isa. So, over time, yung R mo, nagde-decrease. So, yung electric field mo ay tumataas ng magnitude. Pero tignan nyo, Q1, Q2, positive times negative. So, negative siya at the start, magiging mas negative siya at the end. So, hopefully, magets nyo yun. Dito naman, positive, tendency niyan is lumaki. Mag-go apart. So, R increases. Dahil dyan, the U, no, potential energy ay bababa. So, kung ito ay positive, ito ay positive. So, ayan. If particles go towards kung ano yung talaga yung pinupuntahan nila, kunyari, ito, pupunta talaga siya towards each other. Pupunta talaga siya, ito naman, magda-repel sila sa isa't isa. Yung electric potential energy mo ay bababa. So, makuha mo yan from the formula and makuha mo rin yun sa ito. Kasi, diba, initially, nag-start sila from rest and nag-move sila towards each other. Nag-move sila, so tumaas yung kinetic energy and bumababa yung electric potential energy. So, yan. I don't know if na-explain ko siya na maayos, pero, ayan. Tandaan nyo lang na as particles go towards where they would normally go, potential energy decreases. So, useful yon mamaya. So, ito yung isang problem. The nucleus of an helium atom contains two protons that are approximately 1 femtometer apart. How much work must be done by an external agent to bring the two protons from an infinite separation to a separation of 1 femtometer? So, madidiscuss ko ito mamaya. Discuss ko ito mamaya sa formula na ito, pero basically, ang sagot is work applied is how much work must you do is equal to U, positive delta U. So, yan. That's KQQR. Compute mo na lang. Lalabas is 2.307 times 10 raised to 13 joules. So, yan. Kinonvert ko muna sa meters, make sure ka na coulomb since protons to, yan yung charge niya. And, ayan. Ayan lang, memorizing nyo lang talaga yung formula. And isang important part dito is, determine mo kung ano yung work and work applied. Kasi magkaiba yung dalawang yan. Sobrang magkaiba. Dito, na-determine ko na work applied siya kasi may word na external agent. Kung walang word na external agent, yun ay work. And different yung formula para sa kanilang dalawa. Okay, next. What is the net electric field, net electric potential experienced by a charge on point P if it has a charge of Q? So, ito yan. So, medyo mahaba na to and feel ko di lalabas. Pero basically, compute mo yung electric potential individually between the pairs and then vector addition ka na lang. So, yan, medyo mahaba pero ganun talaga. Pero, kung papansin nyo, pwede ka actually mag-cancel out dito. Ngari yan, 5, if 5, -2, -2. So, ayun, aralin nyo na lang kung paano yan. Same to, magka-cancel out. So, yun lang. Yun lang. Yun lang. I think, kaya, di yan lalabas. Ito, feel ko lalabas. What is the net electric potential energy by two electrons separated by 2 nanometers? If the separation increases, thus the potential energy increase or decrease. Okay. 2 electrons. So, clear ko lang to. And 2 electrons. Since same charges sila, ang tendency nila is to move away from each other. If the separation increases, which is yung tendency, does potential energy increase or decrease? Ang sagot is decrease. Kasi, ayan, if charges go to where they would normally go, kung ano yung tendency nila, ang sagot is decrease lagi. So, ayan. What is the amount of work done by an external agent required to set up an arrangement above if Q equals 2.3 picocoulombs and A equals 64 cm and the particles are initially infinitely apart and at rest? So, amount of work by an external agent, yung formula is APP equals KQQ over R. So, yun lang. Plug in nyo lang sa formula and yun na yung sagot. Identify nyo kung work applied or work lang. Then, kunin mo lang yun sa formula. So, ito yung mga formula. Work, pag work, yun ay work done by the electric field. Equal yan sa negative delta U, kung ano yung change in potential energy, is equal to negative Q delta V, yun yung charge nung test charge Q times the potential difference is equal to the negative work applied. So, yan na yung general formula. Memorize nyo na lang yan. And i-apply nyo na lang mamaya. Ito na yung isa pang formula. So, magamit natin yan mamaya. Okay. Ito. 2 protons repel each other. Consider the first proton as the source charge and the second proton as the test charge. Is the work positive, negative, or 0? So, walang sinabing external agent, so ang work dyan is W. So, is the work positive, negative, or 0? So, sabi dito, they repel each other. So, drawing mo yan. So, they have the tendency to move away from each other. So, if they have the tendency to move away from each other, yung delta U mo is negative. Diba? Kasi, nagde-decrease yung potential energy. Then, balik ka sa formula. Work by the electric force is equal to negative delta U. So, ito ay negative of a negative. Yung sagot ay positive. The work here is positive. So, the work by the electric force is positive. Pero, yung work applied is negative. So, ang work applied equal yan sa delta U. So, ang delta U ay negative. Ang work applied is negative. So kung may word dito na external agent, ang sagot is negative. Pero since wala, sagot ay positive. So yan. Does the electric potential energy decrease, increase, or stay the same? So ang sagot dyan is decrease kasi they would move towards, they have the tendency to move away from each other. And since they would repel each other, pupunta sila kung saan sila normally nag-go, potential energy will decrease. One more way to answer this is through this formula. Ang nangyayari is, as they would, kanya itong proton na to, as it goes away from this proton, ang velocity niya is nag-increase. So, pag ang velocity nag-increase, ang kinetic energy nag-increase. Pag nag-increase ang ang kinetic energy, ang potential energy ay magde-decrease. So, yan. Ang sagot dito is positive, ang sagot dito is negative. Please ko nga, positive and negative. So, yun lang yung mga natatandaan kong problems. Hopefully, yun lang yung mga lambas. Pero, ayan. Good luck sa atin guys. Nakalink sa description lahat ng source materials. Okay. So, ayan. Good luck. Sana makapasa tayo.